This particular standard is going to help us prepare for when we get to rational functions. So this is like a prerequisite, just kind of wrapping our heads around the idea of limitations in rational expressions and everything else. So what I want to do here is, we talked about this a little bit today, I've written out the steps to solving rational inequalities right up here. So I'm going to use this as a reference as I go, and as I recommend, maybe stop the movie or pause it for just a second, or the show here, just to write down these steps if you need to. Otherwise, I'm going to walk right through them, and we'll kind of talk about them as I go. So the first thing is, this inequality comes into play when we start looking at the regions and testing things. But in the first kind of step here, it says write the inequality as an equation and solve the equation. So we're going to find a critical point doing just that. So we're going to have 4x, x minus 1 is equal to 7. So when we do that, we get, we're going to multiply both sides by x minus 1. So we multiply both sides by x minus 1. And then we get 4x plus 2 equals 7x minus 7. All right, so we should be pretty good from here. We can, simply solve this thing as we usually do. I'll kind of do it quickly just to save time here. So we get an expression of negative 3x equals negative 9, and then we get negative 3 divided by negative 3, and x equals 3. So one of my critical points is 3. So now I'm going to kind of erase that. Kind of save space a little bit, trying to keep these inequalities steps up here. All right, so now I know that one of my critical points is 3. So now I'll kind of go over here, and give me a second here while I use my magical eraser to get rid of this lines that are made on a computer, which is kind of crazy. I know one of my critical points is going to be x equals 3, okay? So at 3, there's going to be a critical point. Or is it negative 3 or 3? I believe it was 3. So I'm going to draw a number line here, and my one solution is going to be, let's see, 1, 2, 3, and I'll go in the opposite direction, negative 1, negative 2, negative 3. Normally I would wait till I've had all my possible critical points before I draw this, but I can kind of see where it's going just based on this picture right here, or this problem right here. So I know that there's a critical point at 3. Now because this is equal to, this is going to be a colored in spot. Okay, it's kind of like a breaking point. We'll talk about this when we look at the calculator and how this works when we actually graph this equation as a function. All right, so 3 is a critical point, and it's equal to, so because this is going to be colored in. Now, there's also another point on here that x cannot equal, and that's where an open circle is going to be made, and that is where the denominator equals 0. Not good in any math equation, and so we're going to have an open circle at 1, because there's no way that this equation can equal 1, or x can equal 1, because then we'd have 0 as a denominator. So we also factor that into play. Right? So that's part 2 here. So on the number line, mark each of the critical points, steps 1 and 2, so that's what I've done there. So let me make some beautiful check marks here as I cross these off. So I've done that, done that, done that. My next step is select a test point in each interval. Now to help me out to just visually see this a little better, I'm going to draw some beautiful blue-eyed little lines here. All right. So I go down here, and then kind of what I can do here is I'm going to just test a couple points. So I'm going to take my original equation here and test 2. All right. So if I do that, let me get my black pen here. So I would have 4 times 2 plus 2 over 2 minus 1 is going to be greater than or equal to 7. So I'm testing this middle part of my boundary, and I get 8, 10. 10 over 1 is greater than or equal to 7. I would say that is a true statement, so I'm going to color that part in. So that's good. All right. Now let's test another point. Let's say I want to test negative 2. So we get 4 times negative 2 plus 2 over negative 2 minus 1. Okay, so in this case I get negative 8 plus 2, which would be negative 6, divided by negative 3, which would be, let me put this down here just so I'm not trying to do this in my head, because I kind of when it gets to negative stuff kind of get kind of confusing. So we have 2 is greater than or equal to 7. Well, we know that's not true, so that takes out everything on this side of 1 is not a possible solution. So now I'm going to test 4. Just to be on the safe side, I'm going to test 4. So I got 4 times 4 plus 2 over 4 minus 1 is greater than or equal to 7. So I get 8. 10 over 3, which should equal to, is that greater than 7? I do not believe so, because this would be about 3.3. So that's also out of the possible solutions. So now I've tested all the solutions, tested all the possibilities, and I found that the only place that this works is in these critical points right here, which is between 1 and 3. So my solution set would look like, if I use interval notation, give me a spot to write this down so everybody can see this. It's easier to erase when I do this way. Work back in time. All right. So if I do that, my solution is it's a regular parentheses here because it's not equal to between 1, comma 3, and this is going to be a boxed in. Okay. So this is the solution to this problem. Okay, so it goes from between 1 and 3 is where this is a possible solution, and you can test any points in here. We could test 2.5, 2.3, 2.1111, and then there's infinitely many solutions here, but it's restrained by the fact it has to stay above 1 and less than or equal to 3. Okay, so that's kind of a probably less stringent problem as this one, even though this one may look like it's busy, but it's really not that bad. One thing I'm bringing into play here is that we need to have our not exponents, but we need a factor here. All right, so this translates into bringing back some old school algebra, stuff that we should be pretty familiar with. X plus 4x minus 4 over, in this case it would be x minus 5x plus 1. Now, what I want to do with this problem is I would like you, I've kind of taken the hardship out of it a little bit, and I would like you to come to class tomorrow with this problem done, with everything that you think the solution is, and hopefully possibly, so I want this to be homework here. And then I would like you to maybe come up with your own problem to test other classmates to test, okay? And I'll have some problems also that we can kind of look around and things like that. But tomorrow, use information I gave you here and the steps that I gave you up here, and then we'll kind of compare answers and see where we're at with this, okay? So thank you very much, and have a wonderful evening.